Okay, this is what I'm talking about. It says please go to learn and attempt lesson 06 and 07. So you can attempt any of this lesson at any time if you, I think all of you already subscribed to 88 Tuition. Then the worksheets as well. Answer all questions, type your answers in a given line. The use of calculator is allowed. Okay, so let's look at what we are going to do today. So today we're going to touch on integers, real numbers, and rational numbers, understanding of BODMAS rule between rational numbers, recognizing different components of real numbers, comparing and ordering of real numbers, and converting recurring decimals to fractions. Now this part here, converting recurring decimals to fraction, I'm not sure whether any one of you already know. Later I will check. Now, I'm going to start this talk about real numbers. So what exactly is real numbers? Anyone able to tell me what exactly do you understand about real numbers? Enlak, are you able to tell me?
Real numbers. Um, um, no idea.
Okay, very simple. Real numbers is like almost everything. Any numbers can be represented on the number line. We call that real numbers. Okay, so it's very encompassing. It's like any numbers, every number that it will be real numbers. Okay, so then now we're looking at real numbers that can be classified into two groups, rational numbers and irrational numbers. Okay, so I realize that some of you are still at prime factorization, prime numbers, and LCM, HCF. So maybe Mr. Koh want to talk about exactly what is rational numbers. Okay, maybe Enlak this time can help Mr. Koh. What is rational numbers?
Numbers which are fractionable.
Oh, wow, what's fractionable and
Sorry.
non-fractionable?
Numbers which can be made into proper fraction, improper fraction, or just fraction,
Okay.
I think.
All right. So let me just help you to be more exact. Okay, I already have a pen. Oh, sorry, I didn't plug in my stylus. Okay, so if you have okay. If any numbers can be expressed as A over B, all right, where B cannot be 0 and A and B are integers. Okay, so as long as any of this number can be expressed in this manner, it will be considered as rational numbers. So some people will be wondering, okay, so if that's the case, now is 7 over 1, oh sorry, is 7 an integer? Okay. So people ask, is 7 an integer? 7 is an integer, so is 7 a rational number? So 7 can be expressed as 7 over 1. Okay, so it is a rational number as well. Okay, let's see. There's somebody that's just on join us. Kaden, is that right? Kaden, can you hear me? Okay, now rational number can be further classified into decimals. So what kind of decimal? Terminating decimal. So the word terminating means it stops somewhere. Okay, so it stopped at 0.6. It stopped at 3.14. So now, then, 3 and 1/8, is this a fraction or mixed number, or is this a terminating decimal? Now, you have to understand that 3 and 1/8 can be expressed as 3.125. So in that manner, it is a terminating decimal. So you see, when you classify under, all these are classified under rational numbers, whether is it a decimal or whether is it a fraction. So when you come to Sec 1, so when you see the numbers, they are broader. Okay, so terminating decimals doesn't mean that decimal has to be like 3.125 or so, but it can be expressed as a fraction as well. Okay, so 3.14. So later I'm going to talk about this 3.14 and so on. Now, what about recurring? Recurring means there's one particular number that repeats itself. So for instance, when I write 0.3 with dot, it means that it's just 0.3333 non-stop. Okay, so if this is recurring decimals, then Mr. Cole would like to ask, what about 1/3? Is 1/3 a recurring decimal as well? So I'm not sure whether you realize one thing. Is 1/3, if you use a calculator, or so just use long division here, 1/3 is actually 0.333. Okay, so 1/3 is actually 0.3. So therefore, if 0.3333 and so on is a recurring decimal, then 1/3 is a recurring decimal. So the next thing is, what about 22/7? Okay. All right, I will talk about 22/7 very quickly. Now you know that 22/7 is a recurring decimal. Then we move on to the next one. The next one is non-terminating and non-recurring decimal. So what exactly is non-terminating and non-recurring? That means it doesn't stop like terminating decimal. It continues. Then non-recurring means the number doesn't repeat itself. Okay, so if you don't believe, you use your calculator, you find out what is square root 2. But one thing about a calculator is the calculator will round up according to the number of decimal places that it allows. For instance, if your calculator allows like 10 decimal places, then you will round up at the 10 decimal place. So actually, square root 2, cube root 5, pi, these are non-recurring decimal. Means until now, it hasn't stopped. The number is like continue, and nobody knows which number is the last digit, that kind of thing. Okay, so it's another interesting set of numbers. So they call it irrational. So actually, if you understand which irrational as compared to rational, okay, so some people sometimes ask you, be rational, so be reasonable, okay, then irrational means cannot be reasoned. The number just continues. All right, so that's something interesting about that. So just now, Mr. Cole say, what do you want to talk about 3.14? What do you want to talk about 22/7? And what do you want to talk about pi? You know, in primary school, they always ask you to represent pi using 3.14 or to represent pi using 22/7. That's because they want you to get a more exact answer. Okay, they want you to get more exact answer. So sometimes in the question, they ask you, use the calculator pi. Okay, so this is a calculator pi. Now, when you use a calculator pi, well, it is still terminating in the sense because it round up for you, but it has got more decimal places than the first two. Okay, so as a result, you need to round. So in actual fact is pi has non-recurring. That means the decimal goes on and on. So these are two round off. So you what I want you to know is 22 over 7 is just a round up for pi. It's not the exact value of pi. 3.14 is not the exact value of pi, but it's just an estimation. So I want to use the word estimation. Okay? All right, I hope what I say is clear for you. If it's clear, can you give Mr. Ko a thumbs up? And then we move on. Okay, thank you, Charlene. Okay, Charlene, Kaden, Unlock, very good. Let's see who else. Okay, Haldon, I also see you. Thank you, everyone. Let's continue. All right, evaluate the following. So before I ask you to evaluate the following, so just now we talked about this BODMAS. So I'm going to just go through this BODMAS. Okay, so what does BODMAS represent? So what is the priority? Now, BODMAS is when you have bracket, that will be your priority. Okay, so when you have bracket, you will do bracket first. Now, what happens if you have more than one bracket? So we have bracket within the bracket. So you will always do the inner bracket first. Okay, so after you've done the inner bracket, then you go on to the next bracket and go on to the next bracket. Then within the bracket itself, you follow the order itself. What is the order? So the order will be multiplication and division, whichever comes first from left to right. Okay, then the next one will be addition and subtraction, whichever comes first from left to right. Somebody likes to use the word first come, first serve. Okay, well, you have to go from left to right. So first come, first serve must be from left to right. Okay, it's not like right to left. Okay, so have to left to right. So with that in mind, maybe I will just do, okay, so when you evaluate, you're supposed to use without calculator, all right? Calculator will help you to check whether you get correct or not. So maybe I do the first one as a example. So in this case, there's no bracket. So we'll do multiplication first. So that will be a 6. And then we have a 10. So 10 plus 6. So the first one answer is a 16. Okay. So in fact, this is more like a revision for you, except that now you have more things. Okay, what are the more things? You have the square root comes in. Okay. And then, okay, let me just do B again and show you. Now B is a bracket first, right? So I will do 3 minus 5. So 3 minus 5 actually gives you a minus 2. And then minus 10 times 3 is 30. Okay, now this is the part that I'm concerned. If you know that if you have a negative number multiplied by a negative number, the end result is a positive number. Okay, so I put a bracket. When you're negative multiplied by negative, you get a positive result. Okay, so if that's the case, then this will be 6 plus 2 minus 30. And of course, your 6 plus 2 is actually a 8. So 8 minus 30, your answer will be minus 22. All right, so B is minus 22. Okay. So maybe I want you to work on C and D. Okay, just now I wanted to say about D. What's about D? Now, when they have a 6 with a bracket, this is actually 6 times 2/3. Now, compared to if you have 6 and 2/3, this is different when you write this way. This is actually 6 plus 2/3. So I want you to distinguish. So the bracket is very important. When you have bracket and the number in front, it means it is a multiplication. But if you just write in this mixed number here, it is just 6 plus 2/3. In other words, 6 and 2/3. Okay, so with that, maybe quickly you do 6 and D and send Mr. Ko the answer. I will